Okay, so so we can start today's session, and I hope you remember the last session. It was about Nodlet. Maybe I can take the syllabus and I can show you. So we have been discussing about an advanced concept, I will say, in ROS 1 called Nodlet, which is very useful while writing high-end applications like if you are working with vision, mainly like perception related application. Okay. So while working with ROS 2, we are using almost same concept in ROS 2 nodes. Maybe we will discuss that later. This approach is also using in ROS 2. So the next concept is again an advanced concept called gazebo plugins. Specifically like normal gazebo plugins and ROS plus gazebo plugins. Okay, I will explain what we are like going to discuss anyway. And in the last session, I have given a very basic idea about the gazebo simulator and also generally robotic simulators. Okay, so why we are using gazebo in this course is that ROS is actually coming along with gazebo and it is having a tight integration with the simulator. Okay, and you can see, like, you may get confused, like there is a official website that is gazebosim.org. This is the official website, and there is another website called classic.gazebo.org. So the difference is that the classic gazebo and this gazebo is actually different in the sense there are version changes and also some back-end differences is there with these two. And this gazebosim.org, the latest gazebo is actually using along with ROS 2, and the classic gazebo is mainly using with ROS 1. Okay. Yeah, so and the tutorial that we are going to discuss is with the classic gazebo. Okay, gazebo 11, I think the version. Okay, so when you install ROS on your machine, okay, so if you just go to the ROS installation, and if you check, you can see the installation of Noitic, right? Currently we are using Noitic, and if you check the installation, you can find a desktop full installation. Okay, desktop full installation. So this is what I am also preferring for this course. So what is desktop full installation? It is actually installing the simulators, then perception package, all the I will say almost all the packages in ROS. Okay, it includes the vision packages, perception, and the simulator. Okay, so that's what we want for this session. So if you install desktop full installation, ROS installation on your machine, mostly like you will get access to the gazebo. Okay, so if you just take a terminal, this is Terminator, okay, a version of terminal. Just type gazebo on your terminal and enter. Okay, and enter, and you can able to see the gazebo simulator. I think last class I have shown you the gazebo. Okay, so this is the gazebo simulator, and like it is not very I mean appealing, I will say. There are so much better simulators available, but because of the compatibility of ROS, I think it will be good if we can use gazebo for ROS based application. Okay, so gazebo is an independent simulator. Okay, independent simulator, but we can work with the integration of gazebo and ROS. Like you can connect ROS and gazebo. Okay, so basically gazebo is having two parts. Okay, a front end and back end. So I can simply show you that. The backend is called GZ server. Okay, backend is a it's basically a server which is doing all the simulation. Okay, so you can start the backend by a command called GZ server. Okay, server currently it's running, And in order to view the front end, it's GZ client. Okay, GZ client. And if you enter the GZ client in the terminal, you can able to see the front end. Okay, but if you don't want to see the visualization, not visualization, the simulation in the front end, you can avoid it, and you can run the simulation only on the server. Okay, so there is an option in Gazebo to isolate front end and back end. Okay, so you may have some questions, so why we don't need a front end? Because in the front end only we are able to see the simulation, right? It is not necessary actually. Like, in order to create a simulation, a robotic simulation, you don't need to see the visualization. Like, whenever we run the simulation, it may give us some topics, ROS topics or something. So in some scenarios, you don't need to run the front end at all. You will get the sensor data as a ROS topic, or like all these things as a ROS topic. Okay, so it's based on our requirement. If you don't require a front end for simulation, you can just avoid it. Okay, so if you avoid the front end, you can save that much of RAM and also the CPU. Okay, and also, like, if you want to simulate a robot in Raspberry Pi, for example, you can run the backend in Raspberry Pi, because backend doesn't have any visual GUI, right? Any graphics capability it doesn't require, but the front end, it's actually required. Okay, but if you run the front end in Raspberry Pi, it will use CPU, RAM, and the GPU, so it will hang mostly, right? So the front end and back end, the server and client, is like a TCP/IP communication basically. Okay, so you can connect the server from another machine as well if you configure the details, the parameters properly. Okay, so you can run the server, or you can run both server and client. So if you run the Gazebo command, it is actually running Gazebo server and client simultaneously. Okay, so just want to show you that, and then maybe I can show you some basic simulation in Gazebo, so you will get an idea about the plugins. That is our topic today. So let me try with some plugins. Description. Okay, I think this example will be good. So what I am trying to show you is that I'm trying to show you a simulation of a sensor called Velodyne. Okay, Velodyne is actually a LiDAR which is commonly seen in the self-driving cars. Okay, so in Gazebo you can able to simulate sensors, then actuators, complete robots. Mostly almost all the components of the robot. Okay, and you can add these capabilities to Gazebo by writing plugins. Okay, so like you can add a new sensor by creating a sensor plugin. You can create a robot model by writing if you want to control a robot model, you can write a model plugin. So like when you load that model in Gazebo, this model plugin will be active and it will do some simulation based on the coding that we have given in the plugin. So mostly we are using plugins mainly for writing sensors and also creating models, and also like if you want to do some world some intelligence in the world. Okay, robot world, you can add that. So world plugin, model plugin, sensor plugin, system plugin, visual, GUI, all these things, I will say all the aspect of Gazebo can be extended by writing plugins. Okay, there are some examples as well. Hello world example is available. We will get back to that. So what I'm trying to show you is that first how how a plugin looks like, or how we can start work with a plugin, or how to interact with a plugin. A simple demonstration. Okay, we are going to see a sensor plugin, which is not purely Gazebo plugin, which is having ROS APIs on it. Okay, so we can write plugins like in Gazebo. We can write pure Gazebo plugins, meaning it only have Gazebo functions. Okay, Gazebo functions. We can write ROS Gazebo plugins, which is having the subscriber, publisher, and everything. So we are focusing on the ROS Gazebo plugin. Okay, and maybe if you want to add any new library to Gazebo for this plugin, you can add that. Okay, you can extend the possibilities of Gazebo by writing plugin, and you can integrate all libraries into it. Okay, so first we can see a small demo of a sensor. Okay, after that we can see the back story of it. Just a second. Okay, so I'm starting a launch file called example.launch from Velodyne description, and so if you check it, there is a RVs actually popped up. Okay, RVs popped up, and there is Gazebo actually popped up. Let me see whether it is working fine or not. It's actually taking a lot of CPU, it seems. Let me see. Okay, yeah, now it's fine. Okay, and let me try to visualize. Okay, Velodyne. Okay, yeah. So I think you guys can see it, right? Maybe I can increase the size, right? So what you are seeing is the visualization of the sensor called Velodyne. It's a LiDAR. Okay, so basically it is actually sending the range values. Like if there is an obstacle, it can come up with the range, okay, of the obstacle. So here from the simulation, what happening is that we are simulating this sensor. Okay, it's actually a real sensor, and we are simulating that sensor called Velodyne. There are two sensors, VLP16 and VLP32. So we are simulating both the sensor, and in order to like just demonstrate or just to mimic an obstacle, we actually put a cube here. Okay, so if you add more obstacle around this sensor, you can able to see it is detecting this obstacle. Okay, so the visualization of the sensor is coming on RVs. It's actually a point cloud topic. Okay, this sensor is outputting a point cloud, and you can easily visualize the obstacles from the RVs. Okay, so this is giving the 3D points, and this sensor is actually giving 360 degree data, 3D data for the robot. Okay, so this thing, what happening is that we are running a simulation in Gazebo, but we are getting the ROS topics in RVs. Okay, we are able to visualize these ROS topics in RVs. So how that possible? How that possible? Because I mentioned that we are integrating ROS API or ROS function into the Gazebo plugin. Okay, so this is a simple demonstration. This is what we are actually trying to implement. We are trying to write some plugins on Gazebo, So first we can see some pure Gazebo plugin which doesn't have any APIs of ROS. After that we will see how to write a basic plugin with a subscriber in Gazebo, okay, with ROS API. Okay, so this is actually the application. Okay, if you want to create a new new sensor or any mechanism, robotic mechanism, you can extend it by writing plugins. Okay, so by the way, maybe if you want to see the plugin, just go to Google and Velodine's description GitHub. Mostly you can able to see the plugin from GitHub. So you can see here the Velodine Gazebo plugins. Okay, so this is what I am talking about. So this is a package which is having these plugins. Okay, you can able to see here there is a CPP file. Okay, so these all are the reason why I am sticking on CPP, guys, because if you want to write plugins and all, mostly the plugins are writing in C++. So you can explore all the advanced capabilities of ROS and Gazebo using C++. Okay, so this is the plugin definition for the Velodine that we have seen. Okay, it is slightly complex for sure, because we are trying to simulate a very complex sensor, and we will see the basic sensor, basic plugins and all, so you will get a clarity how to configure it. And here is a launch file to start the plugin. I think yeah, this description now. If you start this launch file, we actually started the example.launch. So this launch file will be starting Gazebo, and then it is spawning the Gazebo model into Gazebo. So actually if you check the Velodine's description, if you check the URDF, you can able to see that. Just a second, let me check that. Okay, yeah, this one. Okay, so what happening is that I mentioned that we can write like world plugin, sensor plugin, then system plugin, GUI plugins, all these things, right? So this is how a plugin package looks like. Okay, inside that there is a template for writing a plugin. So you have to write your plugin, and you can create a plugin. Okay, and in order to start the plugin, you can load it through URDF or the world file, or in a launch file you can simply load it. Maybe I will explain it later. Okay, so you will get a clarity after this. Or in a world file you can simply load these plugins. Okay, so the main file when we play with Gazebo is called .world or .sdf, but you can work with ROS and Gazebo using URDF. Okay, so commonly when you work with ROS, we will be like creating a URDF file for simulation, right? And so during the simulation, what happening is that the URDF is internally converted into SDF format, which is compatible with Gazebo. Okay, and whenever these conversion happen, the Gazebo plugins that is mentioned in the URDF is also loading. Okay, so that's how these things are working. I know it's slightly confusing, but maybe when we start doing the plugins, you will get a clarity. Okay, so I just showed the demo. Maybe I can show you again. We are starting a launch file called example.launch, which is from ROS. Okay, then this launch file, what it does is that it will be loading the Gazebo, and it is loading the the Velodyne plugins, and so when you load this, it will be simulating the actual Velodyne. And if you want to visualize it, just change this point to square and just increase the size of. So you can able to see here the plugin that we have loaded in the gazebo is generating the points around it. Okay, it's actually working as a real sensor. Okay, so it is detecting this obstacle, and that obstacle is clearly visible here. Okay, so it is able to detect the obstacle. So here as well you can see it is detecting the obstacle. Okay, so the plugin is working in gazebo, and we are getting this point cloud topic in ROS. Okay, so this is what the demo is. Now we can go to very basic example for the gazebo plugin. Okay, so maybe I can send you the link. So this is the first example that we are going to see. Yeah, it's a hello world for the gazebo plugin. So I mentioned that there are mainly we can either create a pure gazebo plugins without having any APIs of ROS or any other library that you can do, or you can write plugins with any libraries, like using ROS we can do publishing, subscribing and everything. Okay, mostly we will be working with the second one, which is having like the plugins with publish topics, services and actions. Okay, but you should also understand how to create a gazebo plugin from scratch without using ROS, like an independent gazebo plugin. Okay, so we are simply following this tutorial. Maybe I can explain as well, so you will get an idea. Okay, so before that I just want to say like the plugins in gazebo, or like if you check the Node-RED, if you check the path planner, controllers, everything, there is a template for each plugins. Okay, so for gazebo there is actually a template, so you can simply take that template and you can simply fill it. That is what we have to do. For example, if you check a basic plugin of gazebo, you can see here this is a template. Like if you want to create a world plugin, what you have to do is we have to create we have to inherit from the world plugin. Okay, so world plugin is what gazebo offering to us. Okay, so anyway, like we can simply try to create this plugin first. Okay, so first let me check whether I have yeah, I have some plugins with me. The basic, maybe I can start from here. Okay, so first what you have to do is you have to install the development packages of gazebo. Okay, so that is what the first thing. Not the gazebo 6 actually, gazebo 9, not 9, it's 11. I think that maybe, yeah, gazebo 11 dev. Okay, maybe I can after installing I can explain. Just a second. Yeah, so if you just go to terminal and if you just try this, I think version, yeah, so in terminal if you type like this, gazebo space -- version, you will get the current version of the gazebo. The currently, like we are using gazebo 11.9. okay, so the first step before starting developing the plugin in gazebo, you have to install the development package, dev package. Okay, dev package in the sense it is having like proper header files and libraries, which is using to create the plugins. Okay, so currently like we have installed this package which will give the packages or like the libraries for working with the plugin. Okay, that is the first step, and then you can simply create a plugin. I'm just following the tutorial. Gazebo plugin tutorial. Okay, I'm just creating a folder because this is an independent plugin, doesn't have any ROS reference. Okay, so just going to inside it, and then I am going to create my first plugin. I'm just given name called hello_world.cc. Okay, and then I'm just copying the plugin code. So this is the plugin. Okay, so you can see here, in order to write this plugin, we need to include a header file called gazebo.hh. Okay, and basically a plugin is a class. Okay, you can see it here. A plugin is a class. So here you can see we created a plugin called World Plugin Tutorial. Okay, that is the name of the plugin. Okay, and the important thing we have to do is that we have to set the namespace into Gazebo. Okay, because the plugin should be inside the Gazebo namespace. Okay, Gazebo namespace, and it should be inheriting from some plugins. Like there are 5 types of plugin, right? World plugin, sensor plugin, system plugin, then GUI, all this type of plugin available, right? So you have to inherit from any of this plugin. Okay, so here they actually inherited from the World plugin. Okay, I hope you are aware of the class and the word inheritance, right? The inheritance is simply like what will I say? Like we will get access to the functions inside this class to this class. Okay, like inheriting, like we know like how we are inheriting the things from our parents, right? The same concept. Okay, so this class is called base class, and this class is a derived class. Okay, so the derived class is inheriting from the base class. Okay, yeah, so this is the constructor of that class. Okay, so constructor, I think you know about the constructor, which is actually executing whenever we create an object of this class. Okay, and the next function we have to create is the load function. So you may have some confusion why I have to use the load function. Can we change to some other name? The thing is that, so when you go to like World plugin, I can show you that. Just a second. So it's actually a template. Okay, so we have to just a sec, plugin API Gazebo. Let me check. Yeah, so Rohan actually explained about the inheritance. Yes, that's good, Rohan. So you can see here, this is the world class, the base class that we have talked about, this world plugin. Okay, so we are inheriting from this class, and there is a function called load plugin, which can be override, and then you can use it for, I mean, any purpose. Like the load is actually the main function here, main or the loop function here. Okay, so it will be like keep on executing. Okay, so here what we have done was, whenever the plugin loads, it will be printing hello world. Okay, and in the load function there is nothing. We just put it as like an empty function. So this is the mandatory function that we have to derived or like override from the base class. Okay, and these all things are like the same. Okay, there is no need to change because into this function we will get some values like the SDF file, SDF pointer, and the world pointer or something. We will get it inside the function. Okay, and after mentioning all these functions, you can also add your own function as well. Okay, there is no restriction, but these are some mandatory function that we have to override. Okay, the constructor obviously we need to, and whenever we create the constructor, we have to initialize this base class as well. This is how we are like initialize the base class. Okay, like after writing the constructor, just give a colon and then mention the base class. Okay, and this is how we are converting this class into a plugin. So there is a macro called GZ register world plugin, and inside that we can simply mention the name of the plugin. Okay, so that's it actually. That's it. Like this is how a basic independent gazebo plugin looks like. Okay, and again we are going to the tutorial. So we have yeah. So the description is also mentioned here. You can you can check it. Yeah, and how to compile it, that is the next question. So it's an independent plugin, so there is no package, or I mean we have to create everything to compile, right? So it's a C++ file, so mainly you can able to compile a C++ file using CMake. Okay, so this is the plugin tutorial. Yes, and what I'm trying to do is I'm just creating a CMake file. Okay, CMake file. So gedit CMake list.txt. Okay, and then I'm copying the CMake from the tutorial. So in the CMake there is nothing more. Like what happening is that in order to compile this plugin, the main library that we require is the gazebo library. Okay, so here we mention the minimum required, and the main package or main development package that we require is the gazebo, and the include directory, link directory, all these things are like we will get it when you find this package called gazebo. And then what we are doing is we are building this hello world.cc as a library. Okay, so all the plugins that you are going to work, even the Node-RED that you are going to work, is actually building as a library. So you can see here hello world is the plugin name, I mean the plugin file name, and it's a shared library .so file, and the file that we have to build is hello world.cc, and we have to link this executable with the gazebo libraries. Okay, so this is the simplest CMake that you will get, and that is in the tutorial. So after creating the CMake, the next thing is like building it. Okay, building the plugin. So just use mkdir, and you can create a build folder. Okay, build folder. So like the same process or same step that we are using to build a CMake based project. So going to the build, and then you can do the CMake space double dot. Okay, so then it will be like finding all these libraries, and let's see how it goes. Okay, so seems like the CMake is done without any error. If there is any error, you can able to see it here. But when you do the CMake, what is the end product? What is the output? We will get the make file, right? We will get the make file. So once we get the make file, yeah, so Bharat is having a question, what is .cc? Yeah, so Bharat, like if you want to write a C++ code, you can put as .cpp, like hello.cpp or hello.cc, or for header files you can use hello.hpp. Okay, so these are some extension that we are using for C++. Okay, yes. So now we have created the make file, and now we can build this plugin. Okay, so let's see whether it is building. So here it is taking some time, but let's see. Yes, so we got the message, like it actually created a plugin called Hello World, and the shared object is libhelloworld.so. So this is the file, or this is the output of the Gazebo plugin. So if you just go to the build, and you can able to see libhelloworld.so. So this is the plugin. Okay, this is a plugin that we can load. Okay, so our plugin is ready. Okay, our plugin is ready, and now we are going to load this plugin in Gazebo. Okay, so what is the expected output? Whenever we load this plugin into Gazebo, we will see a hello world output, because whenever the plugin initialize, it will be initializing the constructor. Okay, it will be calling the constructor. Okay, so we can able to see the message. Okay, so for initialization, there is one more steps actually pending. So in Gazebo, when you work with plugins, you have to set a path actually. Okay, because Gazebo can't find all the plugins in the system. Currently there is a plugin here, right? But when you try to load this plugin, Gazebo should know the path. I mean, where is this plugin located? Where is the path of this plugin? Okay, so for that we need to set a variable. Okay, a shell variable. Maybe I can show you that. So that is this command. Okay, so no need to fear or something. It's a very simple command. What we are doing is we are setting the build folder inside the Gazebo plugin path. Okay, so Gazebo plugin path is actually a variable, shell variable. Okay, shell variable. So what we are doing is we are exporting the current Gazebo plugin path as Gazebo plugin path. This convention actually the existing plugins path. Along with that, we have to add the current new plugin path. Okay, maybe I can explain it again. So if you run this command, what will happen is that the Gazebo plugin path, okay, which is actually the variable we have to set, then only Gazebo can find the plugin. The current value of the plugin path is currently there is already a value in the Gazebo plugin path. Okay, so that path plus this path. Okay, for example, if you simply echo Gazebo plugin path, you may get maybe some values. Let me check. Yeah, so you can see there is a plugin path already I created for the another package, similar package. So there is a plugin path here. So similar to that, I am creating another plugin path for Gazebo plugin tutorial. Okay, so this actually added the build folder location, that is this location, to the Gazebo plugin path. Okay, and then the next thing, we have to load it. Okay, we have to load it. So now how to load it, that is the next thing. So just switch to the package and then just create a world file. Okay, world file is actually SDF file only. Okay, so this is how we can load a plugin. Okay, you can see here SDF file and all. So this is how we can load a world plugin in specific. Okay, so like inside the SDF you can mention the world name, and also if you want to load the plugin you can mention the name of the plugin. Okay, and yeah, I think that will be good. And yeah, so we created the hello.world which is the simulation description format. Okay, which is having the links, joins, plugin and everything related to the simulation. So when you simulate a URDF, first it is internally converting into SDF, and then it is loading all the links and joins and all the plugins. So currently what we are doing is we are directly writing an SDF file with the plugins. Okay, so we have created hello.world, and then we are going to load this plugin. Okay, let's see whether it work or not. Using GZ server only we are loading, and it is loaded. You can see here using GZ server, what we can do is we can simulate a world file or the SDF file. So you can simply give like GZ space hello.world, and this thing now, the verbose will be printing the messages like what actually happened with this. Okay, without the verbose I think maybe you will not able to see much things. Let me check. Maybe you can see the hello world only. No, yeah, hello world only we got. Okay, but the verbose will give you a clear-cut idea what is actually going. You can see here it actually started the Gazebo, then waiting for master, connected to Gazebo master. So in Gazebo also there is a master based communication. It is also having topics. Okay, but we are mainly working on the Gazebo ROS side, so we are only care about the ROS topics. But if you want to work with Gazebo only like an independent mode, there is some other things to learn, like there are some Gazebo topics very similar to the ROS topics. Okay, yeah, and now it is loading the world file, and then when the world hello.world loaded, it is also loading the plugin, and we got the output as hello world. So this is a very simple demonstration of how a plugin work. Okay, currently you can see it is the plugin actually loaded along with the Gazebo server. Okay, so similar to that, you can extend, you can write plugins to create a sensor, or if you want to add in the world, you can add that. Okay, so this is how we can create an independent ROS, not ROS, an independent Gazebo plugins. Okay, maybe I can switch to the Gazebo ROS plugin because it's almost similar. Only difference is that we need to create a ROS package, and we need to include the ROS API. Okay, maybe I can simply show you an existing ROS Gazebo package. So I created a simple package from a tutorial. I can share that tutorial as well. Just a second. Let me take that. Yeah. Not this. So that tutorial is having yeah, let me share that tutorial. So this is the tutorial that I am following. So the tutorial is very simple. Like, first maybe I can show you that tutorial. First we are taking we are creating a new package. Okay, and if you see the command for creating the package, you can check the dependencies. So two dependencies are gazebo_ROS and ROS CPP. Okay, so this package is one dependency when you start working with Gazebo and ROS. Okay, and so what happening is that maybe I can explain it using a PowerPoint. Just a second, guys. Okay, so we have Gazebo with us. Okay, imagine this is Gazebo, and inside the Gazebo we can write plugins. Okay, plugins. Okay, so we can able to write like 5 types of plugin. Okay, and we have ROS here. Okay, ROS here. Okay, so now we are mainly interested to work with ROS. Okay, but Gazebo is an independent simulator. Okay, so in order to connect Gazebo and ROS, what the ROS developers did was they created a plugin called Gazebo ROS plugin. Okay, Gazebo ROS plugins. So the Gazebo ROS plugin is one of the main plugin which is connecting ROS and Gazebo. Okay, it's connecting ROS and Gazebo. So how it is connecting? Like, you can load a robot model from ROS into Gazebo. Okay, if you write a robot model URDF file, you can load into Gazebo, and then you can interact with Gazebo from ROS. Okay, so that is called Gazebo ROS plugin. So if you just check Gazebo ROS plugin, I think you will get a package. Yeah, Gazebo plugins or Gazebo ROS packages. This is the main package, and you can see the description: interface for ROS using Gazebo simulator. So this is actually connecting ROS and Gazebo. Like, you can interact with the Gazebo simulator using with the help of this plugin. Okay, and also in order to work with ROS and Gazebo, there are many plugins already have written. Like, if you want to create maybe a differential drive robot, a camera, or anything, like, we will have we will get many plugins that is already available. So if you want to add a laser scanner on your robot, you can simply take a ROS laser plugin, which can give you the ROS topics of laser scan. Okay, so it will be like publishing the laser scan data. Okay, and maybe I can share this list of plugins that is already available. So these all plugins are Gazebo ROS plugins. Okay, meaning you can load these plugins on your URDF file. Okay, and then after loading, you will start getting the sensor value. Okay, so if you want to simulate a autonomous robot or like a robotic arm, you can simply reuse these existing sensors. Plugins mainly sensor plugins, and you can able to work with it. Okay, like the real robot. Okay, there is a differential drive plugin like that. There are list of plugins available. Okay, so there are Gazebo plugins and there are Gazebo ROS packages, which is actually helping us to interact with the Gazebo from ROS topics. And yeah, so that is a basic thing. And yeah, so let's start with the Gazebo ROS plugin. Okay, so the maybe we can first check the CPP code, how it is looks like. Is there any different, guys? Like we can see just a second. Yeah, we can see the world plugin tutorial here, right? World plugin tutorial. Inside that there is a subscribe. Okay, the load function is there. Okay, then everything is same, only we have added a subscriber. Okay, we are using ROS.h, we are using string.h. That is the main difference. So whenever we load this plugin, a subscriber will be starting. Okay, and whenever we publish any data to this topic, it will be just printing. Okay, so this topic is subscribing and just printing its data. Okay, so that is what this plugin is about. And the main thing is that how to start this plugin, how to mainly how to load this, and all this stuff is the rest of the things that we have to cover. So maybe I can take the tutorial, that would be best. Let me take it, just a second. Yes, just a second. Gazebo plugin tutorial. Okay, I think the link that I have sent was different. Let me, yeah, I think hello world tutorial, plugins connect ROS. I think the first link, yeah, I got the correct link, guys. Sorry for the confusion. So this is the tutorial that I am talking about. Okay, this is the tutorial that I am talking about. So these are the instruction. Maybe I can simply go through it. Yeah, I was using the same link. Okay, I forgot. So here you can find almost same things that we have seen in the previous plugin, that is the Gazebo plugin. And the difference is that we are using ROS.h here. Okay, and in the load function we are just using is ROS initialized, and we are just printing hello world. Okay, using ROS info. That is only the difference. So what I'm trying to say is that the Gazebo plugin is a C++ based plugin, right? So you can add any libraries into it, including ROS. Okay, so what you have to do is you have to compile the Gazebo plugins with ROS library. Okay, so that is actually happening, the trick actually happening in the CMake file. Okay, so in order to create a Gazebo ROS plugin, the first thing you have to do is you have to create a package. Then you have to mention, or you have to like save this sample plugin, and then the important part is happening in the CMake. Okay, so basically it is depending on the package is depending on ROS CPP and Gazebo ROS. So in order to build, what you have to do is you have to compile it with Catkin and Gazebo libraries. I can take that CMake list. So this is where the difference comes, guys. You can see here we are compiling this plugin, okay, called symbol world plugin.cpp, okay, and you're compiling with, or you're linking with, Catkin libraries and Gazebo libraries. Okay, for the first plugin, Gazebo only plugin, we only linked with Gazebo libraries. So that is the difference here. Here we are linking with ROS libraries. Okay, so that is the main difference. And not only in the linking, if you check the include directory, you can see we are including boost include, Catkin include, and Gazebo include. That is a main difference because we are linking with ROS APIs or ROS libraries. Okay, so if you want to integrate any libraries, you can do that in the CMake. Okay, so this is what the main difference, and after that all the steps are same. So like for the world file, you can see the same template. Like we are like loading this plugin called libgazebo tutorials, and we have a launch file basically. So in this launch file we are starting the Gazebo and the world. Okay, just a second. So you can see here we are starting the launch file to start the Gazebo, and then this thing is actually what happening is that we are passing this hello.world, which is in the Gazebo tutorial that we have created, into the empty world.launch. Okay, so what happening is that this launch file is already available in the ROS installation. When you install ROS, you will get the Gazebo ROS package, and there is a launch file called empty world.launch. So we are simply passing the hello.world file into this launch file. So the empty.world.launch will be loading this world. Okay, so maybe I can simply start it, and we can just see what will happen. There is another thing also, like, but I can explain that. Let me start this, okay, and then we can let's see. Okay, so you can see here our plugin is actually loaded. Okay, our plugin is actually loaded. We got the hello world message. Okay, not only that, if you check the ROS topic list, you can see the topic called test topic. This topic was from what? This topic was from the plugin. Okay, so if you just publish something on this topic, then what happening is that inside the plugin it is subscribing. Okay, so we can simply put like hi Lenton and rate 1. You can able to see the plugin is subscribing it and it is printing. Okay, so what happening now, like there is Gazebo and we are interacting with ROS topic. Okay, like we are simply publishing some topics, and it is actually subscribing in the Gazebo side. Okay, so there is a connection with ROS, right? Like we are interfacing ROS and Gazebo through a plugin. Okay, and one more important point, like when you create a package, there is a tag called export tag. I think I have mentioned that while explaining the nodelets. Okay, so in order to add the Gazebo plugin into a ROS package, we need to like mention this path simply. Okay, you can simply mention like Gazebo ROS plugin path, Gazebo media path. Simply you can add that. Okay, so that is the setup instructions to create a ROS Gazebo plugin. Okay, it is same as the Gazebo, only difference is that we are loading the world using a launch file now. For the first plugin, we loaded using GZ server. Okay, because for the first plugin it was only Gazebo plugin, but this is a ROS Gazebo plugin, so that we can start it using a launch file. Okay, and the main difference is that it's in the CMake. We actually compiling and building this plugin using ROS API and Gazebo API. Okay, so that we can able to use ROS functions inside a Gazebo plugin. Okay, and this plugin, whenever it is loaded, it is printing hello world, and then it is having a subscriber. You can add anything into it, so you can like publish something into this topic, and then it will be like printing it. Okay, so this is what the Gazebo ROS plugin is about. Okay, so this plugin can be any, I mean, it can be like a very complex plugin, like it is like the Velodyne plugin, which is publishing the point cloud. So you can extend it. Okay, yes. So I think we have covered the basics of Gazebo plugins. Okay, now I think I am planning to conclude for today. So next week I am planning to discuss with the path planner. If I'm missing any topics, I will be covering at the end. No worries. So next week, not next week, maybe tomorrow, I am planning to discuss another advanced concepts like ROS path planner and RVS RQT plugin. So again, these are very similar to the Node-led Gazebo plugins. I mean, everything is kind of plugins. Okay, so the template is almost the same. Okay, so we can see the path planners and RQT plugins with an example. Okay, it's mainly like seeing the template, and yeah, that's it. Okay guys, so we can conclude. So it's a time for questions. So if you have any question, let me know. You can ask me now, or you can simply comment so that I can reply. Okay, so time for question, guys.
Yeah, hello. I have a question like, so this plugin is specific to sensors, or is a robot with a sensor?
No, like it is actually specific to, I mean, if you want to create a sensor plugin, you that is specific to the sensor only. Like the robot, the sensor is actually the part of a robot. Okay, like, but all the things are separate only. Like we have the sensor, actuators, all are different, or all are separate, and all these plugins are only for that specific thing. Like for example, you have seen the Velodyne plugin or Velodyne sensor simulation, right? So we have a plugin for that sensor. Okay, and also there are plugins for a robot. Like there is a plugin called differential drive plugin. So that plugin is applicable for like simulating the differential drive for a robot. Okay, so like you can see it here. So the code of that is also available. So it's actually maybe a model plugin. Okay, it's a model plugin. So you can use this plugin for a model, basically a robot, or you can write it for a sensor, or like it's a system plugin, or any kind of plugin, depending on the nature of the plugin that you are writing. Yeah.
Okay, so can you share if you have anything on RealSense camera
Yeah.
plugin,
The
something
actual
like this?
RealSense camera code is actually available. So if you simply go to RealSense Gazebo plugin, you will get the repository. That's it. I mean, all this code, no, it's everything is open. So this is from the Pal Robotics that we are using. So I'm just sharing it. So you can able to, I mean, yeah. So this is a plugin. You can simply check it. Just a second. Yeah, RealSense plugin. This one will be the, yeah, you can see here the same functions, the load functions here. Then I mean it will be like loaded with a lot of function calls and all, because it's a complicated function, I mean complicated plugin. And yeah, so this is how a RealSense plugin looks like, and we are simply loading in our URDF or in our world file. Yeah.
Okay, yeah, thank you.
So almost all the plugins, like if you simply check Gazebo ROS plugin list, you will get the Git repository. So that is having the existing plugins. So you can simply check its code as well. There is a tons of code available in the SRC. This is the Gazebo plugin package, and inside the SRC you can find all the existing plugin. So you can find ROS IMU, ROS laser, skid steer. I mean, we have seen the plugin list from here, right? The code is available for that here. Okay. Yeah.
Okay, yeah.
And there is a template is also available, like Gazebo ROS template. That is what we have seen here. Like this is what the templates looks like with the load function. Yeah, I think we have seen that. Yeah. Okay. Yes.
Okay, yeah, thank you.
Any more question, guys? Okay, so if you are not having any question now, you can maybe post later. Okay, when you start working on it. Yes, so I think we can conclude for today. So tomorrow we will be like discussing a new topic, which might be the path planners or the RV's RQT plugin. Okay. All these are very similar template. There will be a template and we have to like fill it. That's it. Okay then guys, thanks for attending. So see you tomorrow. Bye everyone. Good night.